Good morning, everyone. My name is Aditi Pawar, and today I will be presenting my DSBDA mini project titled F1 Position Predictor. This project uses machine learning to predict whether a Formula 1 driver will finish on the podium in the points or outside the points based on pre race information like grid position or and team. So, the agenda, here's a quick overview of what I will be covering today. I will start with the problem statement, then walk through the dataset pre-processing, the machine learning model results, the front end, and finally a live demo before concluding. So, the core question we are trying to answer is, can we predict an F1 driver's finishing outcome before the race starts? Predicting the exact uh, finishing position like P7 or P8 is extremely difficult even for professional analysts because there are too many variables like safety car or crashes, etc. So instead, we simplified the problem into three meaningful classes. First is podium, which is position from 1 to 3. Second is points, which is position 4 to 10, and no points, which is position 11 and beyond. This is a three class classification problem. Then a data set overview. So we used the F1 World Championship dataset from Kaggle, which is completely open source and free. It contains over 70 years of real race data across four CSV files, results, races, constructors and drivers. We merged all four files together and filtered the data into a modern era. That is from 2000 to 2024 to keep it relevant to today's time. After cleaning, we had approximately 8,000 to 10,000 clean race entries. Then the pre-processing pipeline has six steps. First, we merge all the four CSVs files. Then we clean the data by removing all DNFs and retirements and dropping rows where the grid position was missing. Then we filtered to 2000 onwards. Next, we created our target variable by bucketing the finishing position into our three classes. We then applied label encoding to convert categorical columns like driver name, constructor, and circuit into numbers. Finally, we did an 80-20 train test split with stratification to ensure all three classes are represented equally. From our EDA, we found out that grid position has the strongest correlation with the finishing outcome, and that constructor dominance is clearly visible in podium rates. Then for machine learning model, we used a random forest classifier from scikit-learn. We configured it with 200 trees, maximum depth of 12, and used balanced class weights to handle the class imbalance in our dataset. We choose random forest because it handles mixed data types well, does not require feature scaling, is resistant to overfitting on noisy sports data, and gives us feature importance out of the box, which is very useful for analysis. The seven features we used are grid position, constructor, driver, circuit, year, race round, and nationality. The model achieved approximately 70% accuracy on the test set. Looking at the feature importance chart, grid position is by far the most important feature, followed by the constructor, then driver, circuit, year, race round, and finally the nationality. Grid position and constructor together account for more than 55% of the total prediction power. This makes intuitive sense if you start from pole position in a dominant team like Red Bull or Mercedes or McLaren. Your chances of podium are very high. Uh, for the front end, we used Streamlit, which is a Python library that lets us build interactive web apps without needing any HTML or JavaScript. The sidebar has drop-down menus to select the driver, constructor, circuit, and nationality, and sliders for grid position, year, and race round. After clicking predict, the main panel um, shows a color-coded prediction badge: gold for podium, blue for points, and gray for no points, along with the confidence score and probability bars for all three classes. There is also an interactive plot chart that sweeps all 20 grid positions to show how the probability changes. The complete tech stack is Pandas and NumPy for data processing, scikit-learn for random forest model, Pickle to save the trained model as a .pickle file, Streamlit for the front end, Plotly for the charts, and Kaggle for open source dataset. The project is just two Python files, train model.py, which handles the data loading, cleaning, and training, and app.py, which is the full Streamlit application. So to summarize, this project successfully demonstrates a complete data science pipeline from raw open source data all the way to an interactive deployed application. The key finding is that grid position and constructor are the dominant predictors of race outcome, which align with real world F1 analysis. For future scope, we can add weather data, qualifying lap times, and upgrade the model to XGBoost for potentially higher accuracy. We can also deploy the app on Streamlit Cloud to make it publicly accessible. And thank you. I will show you a live demonstration. So now I've opened the live application. I have run the command streamlit run app.py in my terminal, and it will automatically open in browser. So let me start with a scenario where we expect a high podium probability. I will select Lewis Hamilton as the driver, Mercedes as the constructor, and set the grid position to P1, which is the pole position. The year is 2023 and the circuit is Silverstone, first one. Now, if you see, and as expected, the model predicts a podium with around 60 to 65% confidence. You can see the probability bars on the left. The podium probability drops sharply as you further move down the grid. Now, if you see, confidence dropped and the podium probability also dropped. Now we are 50% confident if Lewis Hamilton starts with a grid position of 14, he will end up between P4 to P10. So a very different scenario. I will keep Hamilton and Mercedes, but change the grid position to 20. Now you see we are just 43% confident that Lewis Hamilton will end up between P4 to P10. And finally, scoring down, you can see the feature importance bar chart. Grid position is highlighted in the red as the most important feature, followed by constructor and driver. This gives a clear picture of what the model considers most important when making a prediction.